Hello friends, in this video we are going to discuss about moment of inertia of a solid cylinder. Case 1, about an axis through its center and parallel to it, that means about the geometrical axis. And there are two cases, first one is this and second one is about an axis through its center perpendicular to it, that means through the axis which is passing through the center and perpendicular to the geometrical axis. Okay, so first in this video we are going to discuss only the case 1 and in the next video we're going to discuss about case 2, right? So now let me discuss about case 1, that is moment of inertia of a solid cylinder about an axis through its center and parallel to it, that means about the geometrical. So before we start the video, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. If you want to follow me on Insta, this is my Insta ID OJHALAKHYAZIT123. that's my Insta ID. Okay, so now let's start. So now let us consider this cylinder. Here you can see, and a cylinder can be considered as it is formed of a large number of coaxial discs. This kind of, suppose you can assume that it consists of large number of discs like this, coaxial discs. That means they have the same axis and each of radius r, which is the radius of the cylinder. Okay, you can consider that way, and the axis of those discs, okay, is the geometrical axis of this cylinder. You can consider that way. So now let me clean this. Okay, so let us consider the mass of the cylinder be capital M. Suppose let us consider a solid cylinder. Let us consider a solid cylinder solid cylinder of mass capital M, radius r, and length L, okay, and length L. So its length is L. Okay, let me consider it. Right, so here x axis is the geometrical axis, of the cylinder. Okay, and so volume of the cylinder will be volume of the cylinder. What will be the volume of the cylinder? Let me consider this as capital V. And now you see, as we have taken the radius is capital R, so volume will be given by area of this cross section into the length, right? So area of cross section is pi r square and length is L, right? So this is the volume of the cylinder, right? And so mass per unit volume, that means density. What will be the density? Let me write it rho. So mass is capital M. Here we have considered mass is capital M and volume we have got. So density means mass per unit volume. So M by volume is pi capital R square L. This is the density, right? So therefore mass will be equal to, mass M will be equal to given that will be given by rho into, which is density, into volume. Okay, pi r square into L. Let it be equation number 1. Let it be equation number 1. So now let me copy this and let me copy the last step. Let me go to the next slide. So here is the diagram and the last step. This is equation number 1. Okay. Now you see, let me consider this is formed of a large number of coaxial disks of radius r, and mass of each disk is suppose small m. Mass of each disk is suppose small m. Let me consider that way. So here we have considered that the cylinder is formed of large number of coaxial disks of equal radius, that is r, and mass of each disk is capital M. Sorry, small m. Okay, this is small m. So we know that moment of inertia of a disk about the axis passing through the center and which is perpendicular to the plane of the disk. Now here you see this axis is perpendicular to the plane of this disk. Here you can see, right? So that is given by half into mass into radius square. This is the moment of inertia of a disk about the axis passing through the center and perpendicular to its plane. Okay, so here we can write that moment of inertia of its disk about this x dash, which is passing through the center of its disk and perpendicular to the plane of the disk. So that is given by half mass of its disk and radius of its disk, right? So this is now, therefore moment of inertia of this cylinder can be obtained by adding the moment of inertia of all the disks, okay, that it consists of, right? So moment of inertia of the cylinder, here let me write moment of inertia of the cylinder about x dash or x dash x, which is the axis passing through the center and parallel to the cylinder. This is parallel to the cylinder, okay, and passing through the center of the cylinder, but this is perpendicular to the plane of its disk, right? Hope you have understood this. So that will be obtained by I is equal to summation of 1/2 m r square. So that's how we're gonna have. So now you see here. Now you see, suppose if you have n number of disks here, then you have to add 1/2 m r square plus 1/2 m r square plus dot up to nth terms, right? So from here what you're gonna have, so here you're gonna have n into this m r square, okay, and suppose if there is n number of disks, then if you multiply n into m, so it mass of each disk into total number of disks, that's gonna give you the total mass of this cylinder formed by this disk, that is capital M. So that means we can say this is equal to half half summation m r square. Okay, if you sum up all the mass, or if there are n disks, then this summation will be n into m, and that's going to give you the mass of the total mass of the cylinder. So here this is going to be equal to half capital M r square. Okay, so this is the moment of inertia of the cylinder, right? And this equation is not used here, and it will be used in the second case, okay, right? So hope you have understood this. So this is the moment of inertia of a cylinder, that about the axis passing through the center and parallel to it, that means about the geometrical axis, right? So this is the answer. Thank you for watching. See you in the next video where I'm gonna continue the second case. Okay.